Hi, everyone. Now this is a complex number. We're gonna go the last two section of the complex. This is the second last, okay? So we go, last time we finished the section 2.6 already. Now section 2.7, the topic is a de Moivre theorems. This one is a one mathematic person name, mathematician name. I believe it's a French, okay? He created this formula, which is really helpful, okay? This one can join with the polar form. Everyone still recall the polar form formula. If polar form formula we have, if we have two complex number, right? Like I say, Z1, complex one, and Z2, then the formula gonna be what? R1, R2, and then CIS and theta 1 plus theta 2. Okay, if complex to complex time or multiply, so the theta gonna be positive, plus it up. If say Z1 over Z2 divide or division, so we're gonna have the formula is R1 over R2, right? And CIS theta 1 minus theta 2. So if divide or division, the formula gonna be theta minus and R over R2, R1 over to R2. It multiply this one plus. See this is a plus when they multiply. And if divide, then this one minus, and the radians of R gonna be, if multiply, gonna be R1 times R2 if divide, so just R1 divide R2. Okay, that's the previous formula. This one polar form. This one called polar form. Okay. So now we come back to 2.7. What is about this theorem? For example, if we have two complex, let's say if we have Z1 equal to R1 CIS C1, and at the same time we have C2 complex 2, another complex number. It's going to be R2 CIS theta 2. So if we use apply from the previous formula of this one polar form, if we want to time theta 1 times theta 2, this one going to be what? Formula time, right? So R1 times R2, and CIS become what? Theta 1 plus theta 2, correct? Okay, one in this one, de Moivre just say if we specific, just say specific, assume this one, let Z1 equal to Z2. Okay, so then if there's Z1 equal to Z2, that means R1 equal to R2 also, and the theta 1 equals to theta 2 also, right? So if in this case, we can say if they're equal, then we just give the simple alphabet. Say just say only Z. And at the same time, we know also R1 gonna be equal to R2, right? And theta 1 equal to theta 2. Okay. So one day this one equal to this one. From this one we can imply what? RCIS theta, correct? RCIS theta. Okay. So we can like at this one. For then if we want to find, say for example, if we time Z to both sides, right? Some Z, if we want to find Z square, like a Z power 2 here, complex power 2. So we can apply, imply to just say if we have theta power 2, that means Z times Z, right? I can say this one, right, equal to this one, just times and Z. So because then this one gonna be R square, correct? And CIS CIS what? Because they're equal, correct? So this one gonna be theta to theta. Everyone get? Right? So for example, if say everyone get now y become 2 theta. That means you get this one, right? Theta z. That means RCIS times RCS. Okay, I like this side. So if I times z, right? So you're gonna have RCIS theta times, right? RCIS theta also. Right now, this one, we try to work this one. So this one gonna be R square, correct? And this is CIS. Then you time this one have to prove. But we can use this one according the formula, right? For the polar form, correct? When z times z, so equal to R1 times R1, right? Because this is R equal, correct? So become R square. And then CIS. And then you get theta plus because it's the time, correct? So that means you're going to have theta plus theta. So this one going to be R squared CIS 2 theta. So that's why we have it here. Okay, that's the one. So, okay. At the same time, if I say I want to time another complex set, okay, time another set. So just say z time another times z squared. Okay. So in this case, this is the whole thing, right? So this z is what? CIS, right? Theta times this one, the whole thing, z squared. So R squared, CIS 2 theta. Okay, so this one gonna be z power 3 cube, right? And R time because the same R, so become R power 3. Don't forget because if we specific this one equal, okay? So that we from here we know R1 equal to R2 also. I will get, and also theta 1 equal to theta 2. Okay, then we can find. Then again, we use this formula multiplication, Z1, Z2, the polar form. So this one gonna be CIS theta plus 2 theta, right? So for now, we're gonna have this one become R cubed CIS 3 theta. Okay, so if this is Z power cube. So again, if I say I want to time another Z, right? So become, this one become what? Z power 4, correct? Then you can see, you can guess next gonna be what? Gonna be x r power 4, right? And then CIS become 4 theta. And then so on. If Z power 5, so R power 5 and CIS 5 theta, and so on. So if you keep doing up to Z power n, okay, you're gonna have R power n, right? And CIS, this one gonna be n times theta, correct? So now we can get the formula, this one now, for De Morey theory, the meanings. See, his theory combined with the polar form is very helpful. You know why? Because if before you just find out like a say like this one, for example, z equal to, for example, say, for example, okay, do example right away on the page. Maybe I write down here. So then see this, go for example. Say express example, express this one, just underline. So express 1 plus 6 1 plus I, sorry. 1 plus I. 1 plus I and the whole thing power 6, right? In x plus yi form. Don't forget x plus yi form, we can call, sometimes we call the name what Cartesian form, or sometimes we call complex form, sometimes we call argand form. Okay, so in this case, you see, before we just find, say, for example, we want find z equal to 1 plus I, something like this, right? So you know how to do. It's a power 1, right? But now power 2 or power 6, how you gonna do? If say I want to find out z power 6, okay, that means you're gonna time this one, how many 6 bracket, and expand, correct? But in this case, we don't need to do that because it take a lot of time. So we apply from the polar form and the De Morey theorem, okay? So in this case, this one we know, like this one, the solution, okay, how to do. So in this inside here, we know z is what? It's a 1 plus 6, right? 1 plus I, sorry. 1 plus I. Okay. So in general, if you find out this one, you want to find, express this one in this form, x plus yi. In general, if we do this one, if question asks this one, correct, z equal to 1 plus I, you know how to do, correct? You just see where the phi r, right? Phi r, so you get the first quadrant, correct? If we do this one. So like x is a 1, so you come here 1, right? And then go up 1 I, so you go up here 1. So you get here, correct? It's the first quadrant. 1, 1 here, and square root is going to be 2. Okay, so from here, you know r equal to square root 2. This is a r. Okay, so now from this one, you know this is a r. So from this one, so we're going to have z equal to, if we write in the polar form, correct? We write the polar form. So to polar form, they call polar form, right? Polar form, we have z equal to remember this one, cosine theta plus I sine theta. Okay, I sine theta. So then we have r equal to this r equal to 2. We have 2 here. And cosine, you just list, right? Cosine, this is theta, correct? So you list cosine is what? Op over sine of over adjacent. This is op add over adjacent, so become 1 over 2. Okay. So you can see this cosine theta, right? Add over hypotenuse, so you have 1 over root 2. So theta equal to 1 over root 2 is a pi over 4, the first quadrant. So this theta equal to pi over 4. Okay, so then you sine cosine, that should be same. So when we get theta, you replace this one, right? So become cosine pi over 4. And then plus I sine pi over 4. Okay, so then if you want to find z, this is a z, right, power 6, so you can have z power 6 equal to, from the formula here. So that means right now n is equal to 6. So, but we know r is a 2, so r power n, so r is 2 power 6. Okay, and cosine, the formula is n here. This one, if you like full writing, is what? From this formula, become r power n and cosine n theta, right? Plus I sine n theta, right? If you like full writing, okay. So mean this, so you're gonna have cosine n length is a 6, right? So 6 times pi over 4. Okay. like the big bracket there, and then plus I plus this one I sine n, right? This one n right now is a 6, so 6 times pi over 4. Close the bracket. So now what we have? 2 power 6 is what? Oh, this one square root 2. R equal to square root 2. Sorry, here. R square root 2. Okay. This one here, R square root 2. Here. R equal to square root 2. So R square root 2 power square root 2, the whole thing power 6, right? This one should be whole thing power 6. So 1 or 2, 2, 3. So 2 power 3, that means 8, right? And then right now you just simplify like we used to do. So 6 and 4 here can cut, correct? So we left cosine 2 over 3 pi plus I sine 2 over 3 pi also. Then you simplify, make it in this pattern, x plus yi. Okay, so what we have, cosine 2 over 3 pi is what? 2 times 180 divided by 3, so 3, 6, so 120 degrees, right? So let's drop in the second quadrant. Okay, drop second quadrant, then this 120. So that means we lead here 60 degrees. So you lead cosine 60 within the quadrant to cosine what? Minus. Okay, gonna be cosine 60, cosine 60 is 1 over 2. Or not? Oh, should be this one pi over 4. Pi 4. Oh, sorry, should be this one when you eliminate 2, 2, and this should be 3 over 2, not 2 over 3. So sorry here. Sorry here. All along this one. Okay, because 6 times pi over 4, then you when you simplify become here, sorry. So it should be 3 over 2 pi. Okay, so then this one wrong. Let's redo this, please. Simplify long. Okay. So now 3 over 2 pi is what? 270, right? Right? 2, 9, yeah, 270 degrees. So drop in this exactly on this quadrant, right? So that's really small here. So you can do by this one, right? Up to here. So cosine 270 cosine is what? Add over to 0 over here. So this one becomes 0, correct? And then for sine is what? Up over hypotenuse, so become 1. But then sine in this quadrant is what? Minus. So this one become minus. So become negative I. Negative 1i. Okay. So then the answer for when writing in this pattern x plus yi gonna be minus 8i. You can leave at this one, or you can write as a negative 8i is okay. Okay, because right now x is equal to 0 and y equal to negative 8. So this finish this example. Okay, this is an example, not too hard, right? Beginning how to how to apply the formula. Okay, if index this one negative, okay, do the same way. For example, if this power is a negative, come back to here, okay? If it become like a power negative 6 here, right? This one power negative 6, you do the same way, right? You do the same way, then when you replace n from the formula, you replace n with a negative 6, that's all. So if you replace this one negative 6, gonna be what? Become cosine negative 3 over 2 pi. And get, okay? And the r here gonna change to Evan. So see this, if I have this a power negative 6, so the z gonna be negative 6 here. and the square root 2 gonna be power -6, okay? And cosine here, you're gonna have -6 times pi over 4, like this, and plus I sine. So I don't really lie, okay, just write down here because we try to finish as soon as possible. So -6 times pi over 4, the same thing. And then you simplify, do the same way. So this is gonna be 1 over square root 2, right? The whole thing power 6, and then you just simplify. So this one become -3 over 2 pi. When cosine negative become what? Plus. So come up, this one gonna be plus sine, correct? But then you have to leave cosine 3 over 2. And then the formula sine negative. This one gonna be this one, right? This one gonna be what? Sine -3 over 2 pi. Okay, so the formula negative sine, like a sine minus theta, the formula I want to remember, equal to sine theta, correct? So this come out, this one gonna be plus here. But then you leave this one, right? Then you leave the sine 3 over 2 pi, and they come the third quadrant sine is a minus. So the final, this one gonna be minus. So they will become gonna be plus. Okay, because this sine negative equal to sine plus, so this should be plus. Sorry, should be plus. So this sine gonna be plus, and then you leave the sine 3 over 2 pi. What the value gonna be? Okay, do the same way. Just replace the, just say the power here, right? The power of the complex number. You just replace with a -6 here. Okay, and this one become -6, and this one going to be z power -6. Okay, one. So I skip this one, and then you can see this example on your handout. Also, if the power negative on the page 19. Okay, so you can compare the same idea how to use. Okay, so we finish this one. Then this one you can do practice exercise 2E, okay? From this one 2E. Now I stop right here first because I'm gonna go find the root of the complex. That's have more way to do. Then I stop this example right here for this section 2.7, and we go the next one, okay?